Hey guys, Elsa the Inequality Queen back talking to you about absolute value inequalities. Now here's a question. Why does Peter Pan always fly? 'Cause he never lands!
First thing we're going to do is review absolute value. So what is absolute value? That's how far a number is from 0 on the number line, also called its magnitude. So here you can see we have some examples. Absolute value of 5 is just equal to 5 because it is 5 units from 0 on the number line. Here the absolute value of 0 is 0 because it's 0 units from 0 on the number line. And then the absolute value of -3 is going to be +3 because it's 3 units away from 0 on the number line. You could also think that no matter what rational number you plug in for this absolute value, the absolute value bars are going to make it positive because magnitude is always going to be positive. Next, let's review compound inequalities. So compound inequalities are mathematical sentences with 2 or more inequalities joined together with either and or. So we talked about this last time. We have 2 types of compound inequalities, and compound inequalities and or compound inequalities. The and compound inequalities refer to the intersection of the 2 inequalities, whereas the or compound inequalities, you get 2 inequalities with the word or in between them. When we graph this, we're going to graph each of them separately on the same number line. Let's also review interval notation. That's a way of expressing an interval without using inequality signs. The numbers are the endpoints of the interval. Parentheses indicate an excluded endpoint while brackets indicate an included endpoint. So here you can see, if we're looking at our and compound inequality here, -7 is less than x, which is less than or equal to 10. So we want everything on that interval from -7 to 10, where 10 is included and -7 is not. So the way we write that in interval notation is we put a parenthesis because that indicates an excluded endpoint, and -7 is excluded because there's no equal sign. So we put a parenthesis, a -7, then a comma, then a 10 because that's our upper endpoint. And since 10 has an equal sign right here, we're going to make it included. So we're going to put a bracket. Over here for our or compound inequality, we make 2 of them separately and then put a u in between them for the union of those 2 intervals. So in the first one, for all x less than or equal to -6, that means we want -6, -7, -8, -9, all the way to -infinity. So we're going to start at -infinity and we put a parenthesis because you can't include -infinity. It's not a point. Then we put -infinity, comma, then we go all the way up to -6. And because there's an equal sign here, we put a bracket because we include -6. Then we join that with our union symbol. That represents our or. And then because we want all x greater than 3, that means we want 4, 5, 6, 7, 8. But we don't want 3 because 3 is not included. There's no equal sign. So we put a parenthesis and then 3, comma, and then we go all the way to infinity and then put another parenthesis. Now let's talk about absolute value inequalities. So absolute value inequalities are just compound inequalities. Get the absolute value by itself on the left side of the inequality sign to determine whether it's an and or compound inequality. So we already talked about compound inequalities. We have and compound inequalities and or compound inequalities. But when it's an absolute value inequality, you need to decide, is it going to be an and or an or? Well, the easy way to decide is to get the absolute value by itself with nothing added or subtracted or multiplied to it on the outside. And once the absolute value is by itself on the left side of your inequality sign, it's either going to be less than or equal to, in which case it's going to be an and, less than, an easy way to remember that. If it's greater than or equal to, it's going to be great or. It's going to be an or compound inequality. So if you have the absolute value by itself on the left side of your inequality, a less than or equal to symbol means it's an and compound inequality. A greater than or equal to symbol means it's an or compound inequality. And that's how you decide. Now let's talk about solving absolute value inequalities. So when solving absolute value inequalities, our goals are to simplify, move, break, solve. This is just like when we solved absolute value equations, except now it's inequalities. So first, we want to simplify each side if possible. After you've done that, then you're going to move the absolute value on the left side of the inequality. After that, you're going to move everything else to the right side. Get the absolute value all by itself on the left side of the inequality. Then you're going to break it into 2 inequalities with opposite signs and expressions. And remember, the expression in the absolute value is always going to stay the same. You're only going to change what's on the other side of the inequality sign. Lastly, you're going to solve each inequality and check both solutions. You may get false solutions. You have to check to make sure they check out.
Who's the smartest Disney character? Gaston. He won the Nobel Prize. Example time.
Example 1 says solve and graph each inequality. Write your answer as an inequality and in interval notation. So here we have the absolute value of x is greater than 8. So what do? Simplify, move, break, solve. Can we simplify? No. Next, we move our absolute value to the left. Done. Next, everything else needs to go to the right. There is nothing else. Sweet. Next, we're going to break. We're going to break it into two separate inequalities. One is going to be exactly what you see. X is greater than 8. The one over here, what's inside the absolute value is going to stay the same. It's going to be X. You're going to flip the inequality sign, and then you're going to change this to the opposite expression. So X is less than negative 8. Now we decide, is this an and or an or compound inequality? As you can see, our absolute value is by itself on the left, and we have a greater. So great or means we have an or compound inequality. Sweet. Now that we know that, we can go and check our answers. How do we check these answers, these possible answers? Well, since it's an or, we need to check both of these. There's nothing in between them because that only happens with an and statement. For an or statement, we check an x value greater than 8 and we check an x value less than negative 8. So I'm going to first check an x value less than negative 8. What's an x value less than negative 8? How about negative 9? So if I plug in negative 9 to my original absolute value inequality, the absolute value of negative 9 is positive 9, and is positive 9 greater than 8? Yes, it is. That one checks out. So this is one of our solutions. Now we go over here. Absolute value of x is greater than 8. I'm going to now plug in an x value greater than 8. So let's plug in 9. What's the absolute value of 9? That's 9. And is 9 greater than 9? Yes, it is. So both of those are going to be our solutions. So when I write this as an inequality for my answer, we need both of these. And since it's an or statement, we separate them with an or. I'm going to start with our lower one. X is less than negative 8, or x is greater than positive 8. Sweet. Now how do I write that in interval notation? Well, remember, they're going to be separated with a u, represents union. So we want each of these to have their own interval. So this is x is less than negative 8. So that'd be negative 9, negative 10, negative 11, all the way to negative infinity. So we start at negative infinity, put a parenthesis. So we got parenthesis, negative infinity, comma, all the way to negative 8. And that's not included because there's no equal sign. So that has another parenthesis around it. Then we're going to put our union symbol. And then over here, we're going from 8 to infinity. 8 is not included because there's not an equal sign here. We put a parenthesis and we put 8, comma, infinity. And then that has a parenthesis as well. Now to graph it, we just graph each of these separately. We have x is less than negative 8. So we're going to go to negative 8, put an open circle because there's no equal sign. And we shade everything less than negative 8. So that'd be negative 9, negative 10, all the way to the left. Again, since our variable's on left, it points in the direction we're supposed to shade. Same thing over here. X is greater than 8. We put an open circle at 8 this time, and we shade everything greater than 8. So 9, 10, 11 to the right. And again, our variable's on left. Inequality symbol points in the direction we're supposed to shade. Part B, doing the same thing. Here we have 1 is greater than or equal to absolute value of p. So simplify, move, break, solve. Can we simplify either side? No. Next, we move our absolute value to the left. Since it's the beginning of the inequality, I'm just going to flip this inequality. I'm going to put the absolute value of p over here. I'm going to put 1 over here, and I'm going to flip my inequality sign. Now my absolute value is on the left. Everything else got to go to the right. There is nothing else multiplied or added or subtracted to our absolute value. So we move to the next step where we break it into two separate inequalities. The first one is going to be exactly what you see here without absolute value. P is less than or equal to 1. Done. Over here, it's going to be what's inside the absolute value stays the same. So P is, and then you flip the sign, greater than or equal to, and then over here, it's the opposite expression, so negative 1. Now we decide, is this an and or an or compound inequality? So when it's absolute value on the left side of the inequality, our inequality symbol tells us whether it's an and or an or. It's less than. So we know it's an and statement, which means we want all values between negative 1 and 1. Now, why didn't we look up here to decide if it's an and or an or compound inequality? Because we decide when the absolute value is on the left side of the inequality. You can't decide whether it's an and or an or if your absolute value is on the right side. It's got to be on the left. So let's check a value between negative 1 and 1 to see if it checks out in this original absolute value inequality. So what's a value between negative 1 and 1? How about 0? So I plug in 0 for p. What's the absolute value of 0? That's 0. Is 1 greater than or equal to 0? Yes, it is. Therefore, these check out as our solution. So our inequality that we're now going to write, since it's an and statement, we start with our lower endpoint. So we're going to go negative 1, and we're going to say is less than or equal to p, because if I were to flip this, that's what that would be, right? Negative 1 is less than or equal to p. And then over here, p is less than or equal to 1. So I have negative 1 is less than or equal to p, which is less than or equal to 1. Sweet. This is how you write an and compound inequality if you forgot. Next, let's write that in interval notation. These are really easy. Since each of these are equal signs, I'm going to have brackets on both sides, and we just put our endpoints in there. So it's going to be a bracket, negative 1, comma, 1, and then another bracket. Now let's graph it. At negative 1, since we have a bracket and an equal sign, I'm going to put a closed circle at negative 1. At 1, since I have an equal sign and a bracket, I'm going to put a closed circle, and I'm going to shade everything between because that's an and compound inequality.
Okay, real talk. Couldn't Elsa have just like told Anna that she had these like cool powers and then like that's why she didn't want to like hurt her? Saves a lot of time. Anyways, you try.
Okay, for part A, again, simplify, move, break, solve. First, can I simplify either side? No. Next, what I have to do is I gotta move the absolute value to the left. So to do that, I take this absolute value y, put it over here, take the 5, put it over here, and flip my inequality sign. These two inequalities are now equivalent, so I can continue. Next, move my constants or everything else to the right. There's nothing else added or subtracted to my absolute value, so I move to the next step, which is break. I'm gonna break this into two separate inequalities. The first is gonna be exactly what you see. Y is less than 5. Without the absolute value sign. The one over here, again, what's inside the absolute value stays the same. It's going to be y. Then the inequality sign is going to flip, and you're going to take the opposite expression than what's over here. So it's going to be y is greater than -5. Now we decide, is this an and or an or compound inequality? Well, with my absolute value on the left, I have a less than symbol, which means less than, which means it's an and compound inequality. Sweet. So I want what's in between -5 and 5. Because of that, I only need to test 1 point. So what's a value that's in between -5 and 5? How about 0? If I were to plug in 0 for y in my original inequality, what's the absolute value of 0? That's 0. Is 5 greater than 0? Yes, it is. Therefore, my inequality checks out. Now let's write this as an inequality. Since it's an and statement, I'm going to write it as -5 is less than y, which is less than 5. Again, there's no equal signs under here, so that makes it really easy. Next, to write that in interval notation, I again see that there's no equal sign, so it's going to be both parentheses for these. And then -5 goes first, 5 goes second. Now we can graph it at -5. There's going to be an open circle because there's no equal sign, so we put an open circle at -5. At 5, there's going to be an open circle as well because there's no equal sign there. And because it's an and compound inequality, we shade in between. And we're done. For part B, again, simplify, move, break, solve. Can I simplify either side? No. Next, move my absolute value to the left. Done. Next, move everything else to the right. There is nothing else. So after that, we're going to break this inequality into two separate inequalities. The first one is going to be exactly what you see, just without the absolute value sign. So it's going to be b is greater than or equal to 4. The other inequality is going to be what's inside the absolute value stays the same. So it's going to be b. We're going to flip our sign, so it's going to be less than or equal to. And then over here, we change it to the opposite expression, so it's going to be -4. Now we decide, is this an and or an or compound inequality? Well, with my absolute value on the left, the inequality symbol is a greater than or equal to. Great or means it's an or compound inequality. Well, since it's an or, we need to check both of these. So we start with our lesser one. We have b is less than or equal to -4. So what's a b value less than or equal to -4? -9. Sure. I'm going to plug in -9 for b in my original inequality. Now, let's see if this is true. What's the absolute value of -9? That's +9. Is +9 greater than or equal to 4? Yes, it is. Therefore, that checks out. Over here, I have b is greater than or equal to 4. So what's a value greater than or equal to 4? How about 9? So I'm going to take 9 and plug it in for b. In my original absolute value inequality, what's the absolute value of 9? That's 9. And is 9 greater than or equal to 4? Yes, it is. Therefore, that one checks out. So when I write this as an inequality for my answer, again, it's an or compound inequality. So I'm going to put each of these separately and put an or between them. I start with my lesser one. I'm going to go b is less than or equal to -4, or b is greater than or equal to 4. Now, how do I write this in interval notation? We start with our lesser one. B is less than or equal to -4. So I want -4, -5, -6, all the way to -infinity. So this one is going to be parentheses, -infinity, comma, -4. And since -4, we have an equal sign right here, it's going to be a bracket next to the -4. Then an or means we're going to put our union symbol. And again, we have an equal sign, meaning that we're going to have a bracket for our 4. And that wants all b's greater than or equal to 4. So 4, 5, 6, 7, all the way to infinity. So it's bracket 4, comma, infinity, close parentheses. Now, we graph this on our number line. We want b less than or equal to -4. So we're going to put a closed circle at -4 because we have an equal sign here. And we want all b values less than or equal to -4. So that would be -5, -6, all the way to the left. Again, because our variables on the left are inequality symbol points in the direction we're supposed to shade. Same thing over here. B greater than or equal to 4 means we're going to put a closed circle at 4. And we want all b values greater than or equal to 4. So 5, 6, 7, 8, all the way to the right. Again, because our variables on the left are inequality symbol points in the direction we're supposed to shade. Example 2, doing the same thing. Simplify, move, break, solve. So first, can we simplify either side? No. Next, we need to move our absolute value to the left. Done. Next, everything else has to go. There's nothing added or subtracted or multiplied to our absolute value. Therefore, we move to the next step, which is break. We're going to break this absolute value inequality into two separate inequalities. The first is going to be exactly what you see, just without the absolute value sign. So it's going to be 2c minus 5 is less than 9. The other one, we keep what's inside the absolute value the same. So it's going to be 2c minus 5. we're going to flip the inequality sign, and we're going to change this so it's the opposite expression. So it's going to be 2c minus 5 is greater than negative 9. Now we're going to solve each of these separately. So here, I'm going to get rid of anything added or subtracted to our variable first. This minus 5 has to go. How do I do that? I add 5 to both sides. That way these cancel out, and 9 plus 5 is going to give me 14. Now to get c all by itself, this is 2 times c, so I do the opposite, the inverse. I divide both sides by 2. That way these 2's cancel out, and I get c by itself is less than 7. On this side, again, add 5 to both sides to get this minus 5 to the other side. That way these cancel out, and negative 9 plus 5 is going to give you negative 4. Then I have 2c is greater than negative 4, so to get rid of this 2, I need to divide both sides by 2 like I did over here. That way the 2's cancel out, and I get c is greater than negative 2. Now I decide, is this an and or nor statement? So I go back to where the absolute value was by itself on the left side of the inequality, and you can see it's a less than. Less than means it's an and compound inequality. So what that means is I need to check a c value that's in between negative 2 and 7. So let's go ahead and do that. I'm going to pick a c value that's in between negative 2 and 7 and plug it back into my original absolute value inequality. So I'm going to pick 5. If I plug in 5 for c, what's 2 times 5? That's 10. And what's 10 minus 5? That's 5. What's the absolute value of 5? That is 5. And is 5 less than 9? Yes, it is. So this checks out. Now I can write my inequality as my answer. I start with my lower endpoint. It's going to be negative 2 is less than c, which is less than 7. Again, neither of these have equal signs underneath. That's why these don't either. Next, let's write that in interval notation. Going from inequalities to interval notation with and compound inequalities is super easy. You just take the negative 2, take the 7. Since neither of these have equal signs, you're going to put parentheses on both sides. Next, we got to graph it. And again, graphing these are pretty easy. We take this negative 2, and since there's no equal sign here, we put an open circle at negative 2. For 7, since there's no equal sign here, we put an open circle at 7 as well. And since it's an and compound inequality, we shade in between.
Who's the funniest Disney character? That would be Rapunzel. You try.
Here we go. Simplify, move, break, solve. Can I simplify either side? No. Next, move my absolute value to the left. Done. Next, move everything else to the right. Well, there's nothing added or subtracted or multiplied to my absolute value, so I'm good. We move to the break step. Let's break this into 2 separate inequalities. One is going to be exactly what you see here without the absolute value sign. So it's going to be negative 3r plus 6 is greater than or equal to 12. The other is going to be what's inside the absolute value stays the same, so it's going to be negative 3r plus 6. We're going to flip the inequality sign is less than or equal to, and then we're going to make this the opposite expression, so it's going to be negative 12. Now we solve each of these separately. To get r by itself, I need to move the plus 6 and the negative 3 to the other side. We start with anything added or subtracted, so I'm going to subtract 6 on both sides to get rid of this plus 6. That way these cancel out, and 12 minus 6 is going to give you 6. Now I have negative 3r is greater than or equal to 6, so to get r all by itself, I have negative 3 times r. I do the opposite, the inverse. I divide both sides by negative 3. That way these cancel out, and I get r is less than or equal to negative 2. Wait, why did the sign just flip? Because I divided by a negative number. Do not forget, when you multiply or divide by a negative number, you must flip your sign in an inequality. Over here, I have negative 3r plus 6 is less than or equal to negative 12. To get r by itself, I start with anything added or subtracted to that, so this plus 6 has to go. How do I get it to go to the other side? I do the opposite, the inverse. I subtract 6 from both sides. That way these cancel out, and negative 12 minus 6 is the same as negative 12 plus negative 6, which is negative 18. Now I have negative 3r is less than or equal to negative 18. To get this negative 3 to the other side, it's negative 3 times r, so I do the opposite, the inverse. I divide both sides by negative 3. That way these cancel out, and I get r is greater than or equal to 6. Wait, why did the inequality sign flip? Because I divided by a negative number. Anytime you multiply or divide by a negative number, got to flip the inequality sign. Now I decide, is this an and or nor statement? So I go back to where the absolute value was by itself on the left side of the inequality, and you can see we have a greater than or equal to symbol. Great or means it's going to be an or compound inequality. So what that means is I need to check 2 solutions, one that's less than negative 2 and one that's greater than or equal to 6. So let's go ahead and do that. First, we're going to check a value that is less than or equal to negative 2. How about negative 3? If I take negative 3 and plug it in for r in my original absolute value inequality, let's simplify. What's negative 3 times negative 3? That's 9. And what's 9 plus 6? That is 15. What's the absolute value of 15? That's 15. Is that greater than or equal to 12? Yes, it is. So this one checks out. Over here, I have r is greater than or equal to 6. So let's pick a value that's greater than or equal to 6. How about 7? I'm going to plug in 7 for r in my original absolute value inequality. Now let's simplify. 7 times negative 3 is going to be negative 21. Negative 21 plus 6 is negative 15. The absolute value of negative 15 is positive 15. Is that greater than or equal to 12? Yes, it is. So both of these check out. I now write my answer as an inequality, and again, it's great or. So it's an or compound inequality, meaning I'm going to start with my lesser one. R is less than or equal to -2, or R is greater than or equal to 6. Here, if I want to write this in interval notation, R is less than or equal to -2. I want -2, -3, -4, all the way to -infinity. So it's going to be parentheses, -infinity, comma, -2. And since there's an equal sign, there's going to be a bracket next to the -2. Then since it's or, I write my union symbol, my U. And then over here, R is greater than or equal to 6. I want 6, 7, 8, 9, all the way to infinity. So it's going to be a bracket for 6, comma, infinity, and then a parenthesis. Next, we need to graph this. So R is less than or equal to -2. I'm going to put a closed circle at -2 because there's an equal sign. And since we want all R values less than or equal to -2, I'm going to shade to the left. Those are all the values less than -2. How about R is greater than or equal to 6? I'm going to put a closed circle at 6, and I want all R values greater than or equal to 6, so I want 7, 8, 9, 10, all the way to the right of that. And again, since each of these, we have our variable on the left, that means our inequality symbol points in the direction we're supposed to shade. Example 3, simplify, move, break, solve. So first, can I simplify either side? No. Next, move my absolute value to the left. Done. Next, move everything else to the right. You see this -5 multiplied to my absolute value? That's gotta go. How do I get that to the other side? I'm gonna divide both sides by -5. When I do that, these are gonna cancel out. That's why I did it. Over here, -18 divided by -5. Look at me dividing by a negative number on both sides. What does that mean? It means I'm gonna flip my inequality sign. Now I have the absolute value by itself on the left side of the inequality. So what I can do, we're going to break it into two separate inequalities. The first is going to be exactly what you see without the absolute value. 2x is greater than or equal to 3.6. The other one, what's inside the absolute value stays the same. 2x, I flip my inequality sign, is less than or equal to, and then opposite of this expression, -3.6. Sweet, let's solve each of these separately. So here, to get x by itself, get rid of this 2. To move to the other side, I divide both sides by 2. That way these cancel out, and I get x is greater than or equal to 1.8. On this side, again, got to get x by itself, so I divide both sides by 2. That way these cancel out, and I get x is less than or equal to -1.8. Now I decide, is this an and or an or compound inequality? Well, when I got the absolute value by itself, I had a greater than or equal to symbol. Great or means it's an or compound inequality. So I need to check answers that are greater than or equal to 1.8 and less than or equal to -1.8. So we're going to check both of those possible solutions. We'll start by checking a value that is greater than or equal to 1.8. So how about 2? I'm going to plug in 2 for x in my original absolute value inequality. So if I plug in 2, what's 2 times 2? That's 4. What's the absolute value of 4? That is 4. Then what is 4 times -5? That is going to be -20. Is -20 less than or equal to -18? Yes. Therefore, that one checks out. Try the other one. Pick a value that is less than or equal to -1.8. How about -2? -2 times 2 is -4. The absolute value of -4 is +4. Then 4 times -5 is going to give you -20. Is -20 less than or equal to -18? Yes, it is. Therefore, both of these check out. Now, how do I write my answer as an inequality? Well, since it's a great or statement, I'm going to write each of them separately and put an or between them. I'm going to start with my lesser one. So x is less than or equal to -1.8, or x is greater than or equal to 1.8. Here, if I want to write this in interval notation, x is less than or equal to -1.8, so I want -1.8, -2, -3, -4, all the way to -infinity. So it's going to be parenthesis, -infinity, comma, -1.8, and since there's an equal sign here, there's going to be a bracket for my -1.8. The or means I'm going to put my union symbol, and then on this side, I want everything from 1.8 to 2 to 3 to 4 to 5, all the way to infinity. So it's going to be a bracket, because we have an equal sign, 1.8, comma, infinity, parenthesis. Now let's graph it. Again, I want all x values less than or equal to -1.8, so at -1.8, which is pretty close to -2, in between -1 and -2, we're going to put a closed circle, because there's an equal sign, and we want all x values less than that, so that'd be -2, -3, -4, all the way to the left. Over here, I'm going to put a closed circle at 1.8, which is closer to 2 than it is to 1. I'm going to want all values greater than or equal to 1.8, so I want 2, 3, 4, all the way to infinity. And again, since each of these, we have our variable on the left, that means our inequality symbol points in the direction we're supposed to shade.
What happens when Olaf throws a temper tantrum? He has a meltdown. You try.
Okay, so again, simplify, move, break, solve. First, can we simplify either side? No. Next, we need to move. Move the absolute value to the left. Done. Next, we need to move everything else to the right. So this 3 multiplied to the front of our absolute value. Got to go. Since 3 times our absolute value, do the opposite, the inverse. I divide both sides by 3. That way these cancel out. I get the absolute value of h minus 4 is less than 6. So now I have the absolute value by itself. So I can break. Let's break it into 2 separate inequalities. First, I have h minus 4 is less than 6. The first one is exactly what you see, just without the absolute value signs. The next, what's inside the absolute absolute value is going to stay the same. H minus 4 is going to go first. Then we're going to flip the inequality sign, is greater than, and then what's over here becomes the opposite, so negative 6. Now I solve each of these separately. So over here, to get h by itself, I add 4 to both sides. That way these cancel out, and 6 plus 4 gives you 10. On this side, to get h by itself, I add 4 to both sides, and negative 6 plus 4 gives you negative 2. Now, I decide, is this an and or an or compound inequality? We look, when the absolute value was by itself, we had a less than symbol, less than. It's going to be an and compound inequality. Okay, that means I need to check what's in between these two endpoints. I'm going to take a value between negative 2 and 10, plug it back in for h in my original inequality. So I'm going to pick 5. I'll plug in 5 for h, and now let's simplify. What's 5 minus 4? That's 1. What's the absolute value of 1? That's 1, and then 1 times 2 gives you 2. Is 2 less than 18? Yes, it is. Therefore, we did it right. Now let's go to our inequality. To write this, because it's an and compound inequality, we're going to start with our lower endpoint, negative 2, and we're going to put less than h, which is less than our upper endpoint, which is going to be 10. Again, no equal signs here because there's no equal signs here. After that, I need my interval notation. So for interval notation, this is super easy. There's no equal signs, so it's only going to be parentheses, and we just do negative 2, comma, 10. Done. Let's graph it. So up here, I start with negative 2. Since there's no equal sign, I put an open circle at negative 2. With 10, there's no equal sign, so I put an open circle at 10. Since it's that and compound inequality, I shade in between those two endpoints, and I'm done. Now we're going to talk about a special case. We simplify, move, break, solve. First, can I simplify either side? No. Next, we move our absolute value to the left side of the inequality. Done. Next, we move everything else to the right. So this plus 7 has to go. What's the opposite of plus 7? That's minus 7. That's how I get it to the other side. I subtract 7 from both sides. That way these cancel out. I get the absolute value of a is less than negative 9. This should look kind of funky to you. Now we think, I have the absolute value by itself, so now I'm going to break. I'm going to break it into two separate inequalities. The first one's going to be exactly what you see, without the absolute value sign. So it's going to be a is less than negative 9, and over here, we're going to use what's inside the absolute value, exactly the same, so it's going to be a. We're going to flip the sign, is greater than, and then it's going to be the opposite expression up here, 9. Now what I'm going to do is I'm going to check both of these just to show you what's going on. So here I go back to my original absolute value inequality. I want an a value that's less than negative 9, so we'll say negative 11. If I plug in negative 11 for a, what's the absolute value of negative 11? That's positive 11. What's 11 plus 7? That is 18. Is 18 less than negative 2? No, it is not. So this is not one of your answers. Over here, I want an a value that's greater than 9. So let's plug in an a value greater than 9. How about 11? If I plug in 11, what's the absolute value of 11? That is 11. What's 11 plus 7? That's 18. Is 18 less than negative 2? No, it is not. Therefore, this is not an answer either, and you write no solution. You could have been tipped off right here when we talked about it. The absolute value of a is less than negative 9. Can the absolute value of something be less than a negative number? No. Absolute value is going to make it positive. Therefore, it can never be less than a negative number. That doesn't make sense. So we write no solution.
What's Tarzan's favorite Christmas carol? That would be Jungle Bells. You try.
Here's the same thing. Simplify, move, break, solve. So first, simplify either side if possible. Done. Next, move my absolute value to the left side of the inequality. Done. Next, move everything else to the right. So this negative 3 has to go. Since negative 3 times the absolute value, I do the opposite, the inverse. I divide both sides by negative 3. That way these cancel out. And now, since I divide by a negative number, I have to flip my inequality sign. So I get the absolute value of k plus 2 is less than negative 4. Uh-oh. You could stop right away and say no solution, or you could continue on. I'm going to now break this into two separate inequalities. K plus 2 is less than negative 4, and k plus 2 is greater than positive 4, right? Because what's inside the absolute value stays the same. I flip my inequality sign, and this becomes the opposite. I'm going to solve each of these separately. Here, I subtract 2 on both sides. I get negative 4 minus 2 is the same as negative 4 plus negative 2, so I get negative 6. On this side, subtract 2 from both sides. I get k is greater than 2. Now I'm going to check each of these separately. So first, let's pick a k value that's less than negative 6. So how about negative 7? Negative 7 plus 2 is going to give me negative 5. Now, what's the absolute value of negative 5? That's positive 5. And positive 5 times negative 3 is going to give you negative 15. Is negative 15 greater than 12? No, it is not. Therefore, this is not one of your solutions. How about over here? K value greater than 2? Let's say 3. I'm going to plug in 3 to my original inequality. And then 3 plus 2 gives me 5. Absolute value of 5 is 5. 5 times negative 3 is negative 15. Is negative 15 greater than 12? No, it is not. Therefore, this is not an answer either. And you could have seen that right here where you had absolute value less than a negative number. Because of this, you write your answer as no solution. Now for our word problem that says the ideal circumference of a women's basketball is 28.75 inches. The actual circumference may vary from the ideal by at most 1/4 of an inch. What are the acceptable circumferences for a women's basketball? So first, step 1 in a word problem, we're not scared. Because of that, I can move to step 2, which is what is the problem asking? It's asking what are the acceptable circumferences. Therefore, in step 3, when I define my variable, I'm looking for the acceptable circumferences, so C is the circumference of a women's basketball. Now when I write my inequality, I use all the other information. I know the ideal circumference is 28.75 inches, and the circumference may vary by at most 0.25 inches. Now let's go ahead and write our inequality using this information. So what can we do? Well, we know the circumference of a women's basketball, the ideal circumference is 28.75, and we have the circumference of a ball. So if we take this circumference and subtract the ideal circumference, it'll give us how much it varies from the ideal circumference. And then that difference has to be less than or equal to this 0.25, because the most it can vary is 0.25. But now, let's say we get a negative number. If you get a negative number in the opposite direction, it shouldn't matter because it needs to vary by at most 0.25, whether it's more or less. So we're going to put absolute value around our difference. So we're going to put the absolute value of C minus 28.75 has to be less than or equal to 0.25 because our difference, whether it's positive or negative, doesn't matter. It just can't vary by more than 0.25. Next, we're going to simplify, move, break, solve. So first, simplify either side if possible. Done. Next, move our absolute value to the left. Done. Next, move everything else to the right. Nothing else to move. So now we can break. We're going to break it into two inequalities. The first is going to be exactly what you see, just without the absolute value sign. The next is going to be what's inside the absolute value stays the same, always. You're going to then flip your sign, so it's going to be C minus 28.75 is greater than or equal to the opposite, which is negative 0.25. Now we solve each of these separately. Add 28.75 to both sides. These cancel out. You get C is less than or equal to 29. Over here, add 28.75 to both sides. You get C is greater than or equal to 28.5. Now I decide, is this an and or nor statement? So I go back to where the absolute value was by itself on the left side of the inequality, and you can see it's a less than. Less than means it's an and compound inequality, meaning we could write it as an and compound inequality. So 28.5 is less than or equal to C, which is less than or equal to 29. Now we can test this out by picking a value on this interval. Let's say 29. Pick 29, plug it in for C. 29 minus 28.75 is 0.25. Is 0.25 less than or equal to 0.25? Yes, it is. Therefore, this checks out, and the circumference can be between 28.5 inches and 29 inches inclusive.